question 1, and I'm looking at a situation where I've got a van moving up a road at an incline. We've got resistance to motion, and the van is moving at a constant speed, i.e. there is no acceleration. The van's got a constant rate of power as well of 25 kilowatts, and we're asked to find these resistive forces. So what I'm going to do first of all is just to draw a little diagram. We've got theta, where we know that sine of theta is equal to 1 on 16. I've got my van that's travelling up this incline. I know the mass of the van is 600, so the weight is here 600 g. I've got my constant resistive forces R, and then the power of 25 kilonewtons is going to be providing me a force that's going to move my van forwards. We know that the speed of the van at this point is 20 meters per second, and as I just said, that power was 25 kilowatts. Okay, so where do we go from here? Well, the first thing that we need to remember is that power is equal to force multiplied by velocity. So I know that this 25,000 is going to be equal to the driving force multiplied by the current velocity, which is 20 meters per second. So that tells me that 1,250 is the force driving the van forwards. Now again, I should remember to decompose any forces that aren't acting parallel to the plane. So my weight, I am going to decompose. I only need actually the bit that's acting parallel to the plane here, which is going to be 600 g sine theta, and again we get that from just drawing our little right angle triangle in here and remembering that the theta at the bottom will be the same as the theta angle up in here. So the two forces that are acting down the plane are going to be R and 600 g sine theta, and the driving force that's acting forward is going to be F. And as we've said before, there's no acceleration in this question, so actually these forces should balance. So that is to say that if I look at R plus 600 g sine theta, what I should get is the driving force F. So rearranging that, I can find out that R is equal to F minus 600 g sine theta, and then making my substitutions, I know that F is 1,250, and I can subtract from that 600 g, and sine theta we knew was 1 on 16, so that goes in here now, and working that all out on my calculator, I get 882.5 newtons. For the second part of this question, the van is going to increase its power output, so we're told that here we're now going to increase to 30 kilowatts. The resistance to motion remains unchanged, and we want to find the acceleration of the van this time. So let's think about this time around. I'm going to need to do the same calculation to begin with for power. So that is to say that power is equal to the driving force multiplied by velocity. So in this case, that's 30,000 is equal to F multiplied by now the current velocity of my van is 20 meters per second. So dividing through, I find out that 1,500 is equal to my driving force. Now I think about resolving forces, and this time I should be left with some remaining force that's going to cause acceleration. So thinking about that, I'm going to think F is driving my van forward, so I've got F, and from that I subtract the resistive forces R, and I subtract the weight of the van acting down the plane, which is 600 g sine theta, and that should be equal to the mass of the van, which is 600, multiplied by its acceleration, which is A. Substituting in the values that I know, we've just calculated our new value for F, which is 1,500. We subtract away the 882.5, and this is 600 g times by 1 on 16, which is equal to 600 times by acceleration. Working out the left hand side, all on my calculator, I get here 250 is 600 A. So dividing 3 by 600, I end up with 5 over 12, 5 over 12, tidy that up, is equal to my acceleration, or to give that to three significant figures, I can say that my acceleration is 0.417 meters per second.